Okay, so the stream crashed, of course, because I was compiling again. Yeah, I'm sorry about that. But in the meantime, I have compiled the code and executed it in the debugger. And as you can see now, as the images are coming in, the frame ID is updating. So this is already like a nice information or good news. The problem with that is this value of the frame ID is not updating until the system is initialized. So even though it is working, it is not working the way I expected it to work, because I actually wanted to know how long I need to wait until the system is initialized. But somehow the data is not passed from the full system to the viewer until the full system is initialized, which is a pity. But yeah. Let's still once again look into the code and see if we can somehow use a different data structure. Just a short glimpse. So this one should not be update the current image index, but update the current image index in the user interface. So the current cam is not available until the system is initialized. So this is something I need to write as a remark here. Okay, so what could be an alternative? Current cam is not useful, and it can also be the null pointer, as I'm seeing here. So this could cause an exception. Oh man, this is really bad, because the keyframes are also not what I want. Okay, so for now I do not have a better idea. That's why I will add a check for current cam. And if this check passes, then I will set the frame ID. And the rest, I will leave the rest for now. I know it's not satisfactorily satisfying in my view, but I need to think about this off camera, I think. What else could we do here? Yes, we can change this draw cam method to show the little coordinate system as well. So let's take a look into that. So here the camera is being drawn. color is equal to 0. If this is the null pointer, then it is drawn in red. Otherwise, it is colored with the color. Okay, so how OpenGL is working in general is we are pushing a matrix. That is, we are storing a matrix on our what is called the matrix stack, which is, by the way, a legacy OpenGL API. So this should not be used anymore. Not sure why Pangolin is using the old legacy stuff, but okay. Then we are multiplying the current matrix onto the stack, which is the cam2world. So we are taking the camera to world transformation to know where in the world is our camera located. And this way we are at the center of our camera, and now we can draw stuff. In order to draw stuff with the legacy API of OpenGL, we can call GL color with several like other endings here, but GL color 3f, for example, will take in a 3D float vector as individual arguments, an argument list of 3 floats, and we'll set this color. So OpenGL is a state machine, and we can set a color. This color here will then be active for every other draw call that we make. So first this color is defined, then a line width is defined, which is passed onto this to this method, and with the settings we can then begin a draw call. In this case we want to draw lines, and those lines are being drawn given those vertices. So we start at the origin, so at the location 0, 0, 0, which is the center of our camera, and we place a vertex here. Then we are placing the next vertex given this formula. So this is basically taking into account our scale factor, our principal point, and our focal length in x and y to determine where we want to draw the line to. So if we have Blender here, again, we want to draw this camera frustum, and we start to draw the first point at location 0, 0, 0. So this is this one here. And then we want to draw this line. Maybe let's take this line here to this point, which is somehow expressed with those values that we have calculated, given the scale factor. So how far do we want to go? How much do we want to go to the right, to the top, to the top, and so on and so forth. So this is perfectly fine. The way the camera frustum is drawn is fine. It would be nice to have this up vector as in Blender, for example, this triangle. So we could add that. But what I mainly want to do is I want to draw this coordinate system here for each camera. And this is pretty easy because we have those glbegin, this glbegin command, and then we have a glend command somewhere. And this will draw the camera frustum. And then we can simply take this and copy this here. And we can draw the camera coordinate axis. And we do that, which is not very... Oh well, I think we can do this way. So, being a state machine, OpenGL will allow us to also call this glcolor3f inside of this glBegin statement. So we can change the states inside of such a glBegin area or region. And I can now define a color for red. And one for green. And one for blue. The x-axis should be red. The y-axis should be green. And the z-axis should be blue. All right. And now we want to draw a line from the origin to the axis that we want to draw. So for the x-axis it would be 1, 0, 0. And in order to make this a little bit more flexible, I would not just use the unit vector here, but I would also add the scale factor or the size factor here that is being passed into this method. So I will just use the size factor here. In this way we can continue and add the other remaining axes. So this one, the y-axis should be this. And the z-axis should be this one. And the rest can be deleted. Like this. Okay, I hope this is correct. Next, we also want to do the same thing with the world coordinate system. So there is the run method with the main loop here. And let's add this here. And I like the idea of having a setting to turn that off and on. So let's copy this. For example, by calling it a world coordinate system. Let's use once for now. And let's change the comment. And let's add this here. World coordinate system. I don't know if this is too long for a name. Let's maybe abbreviate with WCS. For now, we can change that later. Or let's say world CS. So will this be true in the beginning? It will probably be true. Value is true and toggle is true. Okay. We'll also add another variable called the world grid, which is also true in the beginning. And for the world grid, we also want to draw GL lines. But these lines should be white. And we want to have a for loop with 10. Ten in X and 10 in Y. And we start with X size divided by 2 with a -1. And here we just say that we want to place the X line with the size of Y size divided by 2, negative. To Y size positive. And then we do the same with the Y direction. I think I'm missing a divided by 2 here. Okay, this should do the trick, I believe. I do not want to compile that, but I will have to. But this way we should have several things now. We should have a world coordinate system, which we can turn on and off in the display, in the UI. We'll have a world grid that we can turn on and off. And we'll have the camera coordinate system also drawn for each camera. I hope this is working, because I do not want the stream to crash and then I need to like fix things. But okay, so I will try to compile again with the fact that the stream might crash. So I'm already apologizing for that. But as a reference, this is how the display looks now. So we have the cameras drawn as those frustums. We do not have a world grid. And now I see that white is probably a bad color for the grid, because it should be black. And we do not have the individual coordinate systems. And we do not have a world coordinate system. And we do not have those settings here. So these will all appear, hopefully. Let's just stop that. And let's change the grid to black. Okay, and now when the stream crashes, I'm sorry about that, but I will be back online once the compilation is finished. So hopefully this will not take a long time. Okay, see you then. The good thing is that it has 3 parts, and I think this was already successful before, so I think that the stream will not crash this time, hopefully. Okay, hoping that the stream will not crash, I will continue with the other part that is still left. That is to import the camera trajectory. And for this I will use a repository which I have created about 6 years ago, which was targeting the sensor data fusion of Visual SLAM and GPS. And in this work I have been using the DSO, so not the LDSO. But I have created a Blender add-on that can import the DSO camera trajectory. And I did that using Python. And the code is available here in this add-on. Directory. So it's in the utilities directory and then in the Blender add-on folder. And there are different versions. So I will maybe post that link into the chat for you in case you want to join me. Okay, so here's the link. I think this is so you can just go to my GitHub account and then download the script there. So in the utilities folder, then Blender add-on, they will see 3 files, and we take the Blender 300.py, which is the updated script for Blender version 3. But I'm using Blender version 3.5 here. So this is 3.51. So I will create a new version that will be called with this version name. How is it looking? Oh, it's finished. Okay, so before we do that, let's continue with this. And let's try to start the debugger. Okay, this is not working anymore. But it was. Okay, something's wrong again here. This is really annoying. I hope the stream is still fine. It looks like it. Okay, let's now play. Thing is coming up. But there's nothing displayed here, unfortunately. Maybe this loop, this running is not set. Maybe running is not set. Where is this variable being set? Running is true. Should work. Running is true. And not should quit. Okay, I'm hoping that this is somehow related to the initializer not being finished at this point, the full system being not initialized. But this would be very weird because this should not have an influence on drawing the stuff in the viewport. Okay, so let's keep this running for now. Let's go back to the add-on. Let's take the raw code and let's create a new Blender file. And let's go in Blender into the scripting layout. Let's create a new text file here. And let's paste in the code. And now when I run this code, I will hopefully not get any errors, which is the case. And I will see that now in the layout, or basically it doesn't really depend on this workspace here, but when I go to the scene settings, I will have this bslam sim add-on where I can now define several things. Let's see. Okay, so this is obviously working with the coordinate systems now being rendered here. But the world coordinate system is missing. Okay, this could be due to the missing setting for the line width. Let's see. Let's copy this setting. At least there is no error. So let's build it again and let's hope that the stream will keep on working. Okay, could be. Now back to this add-on here in Blender. So what this add-on will do, it will help in creating several properties related to a dataset for VisualSlam. And for this I first need to define an output directory. For example, documents. Okay. So when I define this output directory here, I can now set a camera which I want to use. And let's say that this camera, for example, is animated. Let's quickly do that. If my Blender will react. So now I have this camera animation. And I can now define if I want to generate noisy camera poses from that. I can put in a additive white Gaussian noise on the position and on the orientation in Euler angles. And here are the settings for that. So the standard deviation is 0.01 for the translation and 1 degree for the orientation in Euler angles. And let's quickly check if something is placed in the documents folder. Something is really laggy. Okay, but here we have the documents folder now. I only have this temp directory, which is not important for now. And let's check. Okay, the build is completed. The stream is still on. If I now am here in Blender with my camera animation, I can now press a button, for example, this export camera poses and project files here. And this will take my scene and my animation and alter the camera that I have selected here to create a noisy camera. And this is how it will look. So I have my new camera object, which is this one that is selected. And I have this other camera object, which is this one. And this is the ideal camera pose. And this one is the noisy camera pose. So you can see if I change to the ideal camera pose and I play the animation, you'll see that the ideal camera pose is, it's just ideally moving. But if I change to the altered camera pose, let's maybe start from the beginning. If I now change to the altered camera pose and play the animation, you'll see that now the camera is just shaking. And I have been using this to generate my synthetic data for GPS, for example. But you could do the same with the IMU or any other kind of data, laser data or whatever. And this is the part that is taking the camera objects within Blender and exporting them. But we actually want to import something here. And currently I can only import the CSV files from the DSO, which is a custom implementation from myself. So I've extended the DSO to export the camera poses, the trajectory, into the CSV file. But actually with the LDSO now, we have different files that need to be imported here. So we need to add a new button here, which where the new button will read import LDSO, and it will import the results.txt file and the results.noloop.txt file. But before we do that, let's switch back to the LDSO here. And let's launch the debugger again. Okay, so it stopped at the main function. And it somehow cannot find the camera.txt file. I'm not sure why this error persists, but I saw this already. So let's restart the debugger and hope that this was just a hiccup. I don't know why this is not working the way it is supposed to work. But now it's just complaining about a camera.txt file, which is there, definitely. Not sure, maybe the IDE needs some updates internally. This is also fine. I can only try to restart the debugger because I really don't know why this error is there. Okay, because now magically it's working. Have you tried to turn it off and on again? Yes, and this works. But I still do not have any coordinate system and no world grid, unfortunately. But maybe they will appear once the initializer is done. Then at least we will know that the reason is the initializer. I will decrease the number of points because this way it will probably be faster with initialization. Okay, while we wait, let's get back to Blender. So we now want to introduce a new button here. That's why I will change to the scripting layout. And now I need to find the buttons, which is here. And here we change the operator to import LDSO. And we change the text for the button to import LDSO. This will look for results.text and a results.noLoop.text file. Let's see if this works or if I need the operator. No, this should work. So now we have no button here because we are missing the operator, but at least there is a little bit more space for the new button. Import LDSO. This is the operator we need. So let's add the operator here. Okay, I will search for it. Oh, my computer is loud. Okay. Still no coordinate system, unfortunately. Okay, I'm missing something, which is probably very obvious, but I don't know what I'm missing at the moment. So let's leave it like that and let's continue with this add-on. So I want to search for the import DSO. Okay, this is the operator that takes in a path, this camera DSO CSV, and loads in the contents of the CSV file. And I will now copy that. So this is the import DSO. And this one will be the import LDSO. Let's change the DSO to LDSO here. text file results.txt. And no loop.txt. Let's save that code to a file in case we will have a crash. And I will later upload this file to the repository. Let's maybe put it to documents as well. And this one will be called 351 for Blender version 3.5.1. Okay, somehow it's not loaded. So let's load it directly. Okay. Import DSO. Import LDSO. You can run that. And the button is still not showing up. Import LDSO. Import LDSO. Okay, we are not registering the import LDSO class. Okay, now it is showing up. We have this import LDSO with a weird tooltip. But at least this should be fine. Let's go back to the implementation of the operator. Import LDSO. So we have this execute method, which will then call everything that is needed to import the file. So here we start with printing something so that we know that this execute method is actually being called. Maybe not of class, but operator. And this execute method needs to return something. Namely, it needs to return finished when it's finished. And this can be saved now. And let's execute it again. Now the problem is that we do not have a terminal window open. So I need to close Blender at this point and reopen it using the command line. And here I can just call Blender. Now we'll load in the Python script again. And now when I execute this Python script, then I will have this panel here again in my scene view, my scene properties. And when I now click Import LDSO, I should see that here in this terminal output, there should be an output for this execution that I just added. Yes, it's calling execute method of operator vslam import LDSO code. Okay, so now we are prepared to write our code. But I also would like to fix this warning. Let's do that quickly. This is vslam tool panel. Okay, I definitely need that. Okay, this should be fixed now. Now, let's take a look at what we want to do here. So we have those results.txt and results.noloop text files. Let's briefly look into them. And by the way, here are the exported files, the camera_camera.txt, which contains the camera.txt file that the LDSO will load. Then we have the ideal camera poses, which are opened in the Office tool. Okay, let's maybe open that, the text editor. So those are the ideal camera poses. And then we have the noisy camera poses here, which is hard to spot. The difference is hard to spot, but those are the trajectories that we have. And ideally, this CSV file will be similar to the text file that we have from the LDSO. So let's take a look at that. So here we have the results.txt file, and this is how it looks. So we have, again, 3 parts for the translation and 4 parts for, I think, the quaternion, for the orientation. And we have a timestamp in the beginning, which is different to the timestamp that I am exporting in my add-on. Well, no, it's not actually, because this is also in milliseconds, I think. Okay, the question is, what kind of format does this represent here? Is it really the translation in the quaternion? Then for the quaternion, is it the W, X, Y, Z, or is it X, Y, Z, W? We need to verify that. For this, let's first open the no loop if it looks similar. Okay, so this is 1 here, and the other ones are close to 0, so I believe that this is X, Y, Z, and W, it seems. But we need to check that, so let's go back to this code. Still not sure why the other things are not showing up, but at least this coordinate system is correct. Let's take a look at the code. So in the main function we have this full system print result. Okay, so now we can see that in fact we are printing out the timestamp, then the translation, the transpose actually of the translation, because we want to have the column vector as a row vector. That's fine. And then we are printing out the unit quaternion of the SO3 Lie group. Let me quickly check what the timestamp is. Unfortunately, it's loading. Timestamp. Okay. This is unclear in what kind of reference system this is. Get all keyframes. This will return a frame. And here we have a timestamp. Unfortunately, it's unclear what this timestamp is measured in milliseconds or something else. Still a timestamp. Okay, we can pause the debugger here. Or rather reintroduce the add active frame and continue. Okay, so now we have a timestamp somewhere. Okay, what was this called? print result. Okay, the print result is unfortunately only called at the end of the image sequence. So I need to stop at the frame somewhere. Maybe when a frame is created. Let's maybe put a breakpoint here and let's continue.